All right, guys, welcome back from spring break. Hopefully, you had a good spring break, relaxing. You got out some fresh air, stayed healthy, but we're ready to get back to work here. Let's talk about homework first, and then we'll talk about the new schedule. All right. So, remember over spring break, you had one homework assignment. It was a worksheet. It was 10.1b. It's basically square roots and estimating square roots. So, as always, I'll post the answers. You check your work, and then you go on Google Forms and you type in how many you missed. So, here are the answers. Go ahead and check your answers, pause the video, and then answer question one on Google Forms. All right, how'd you do? Okay, we are going to move on. Here's the new schedule. Obviously, today is Wednesday. Every Tuesday and Thursday is going to be a tutoring day. If you need specific help, send me an email and I will respond. Um, Obviously, we're giving you a little bit of extra time to get your homework done as well too. So really try to work hard on understanding what is going on. I know this isn't the perfect scenario. I'm not there to look at your paper and help you individually in a time-wise fashion. However, let's make the best of this and let's learn some math. All right, so let's see. We're doing 10.2 today. The next quiz or test will be at the basically 3 weeks from now. So we got a long time to go before a quiz or a test. All right, so hopefully we'll fall into a pattern of work, and this will be comfortable. And here's your homework tonight. One quick note: this is from the book. And the instructions don't. I think the instructions say around the nearest thousandth. You're going to understand why I'm cutting you some slack here and making you only run round to the nearest hundredth. And also, you don't need to go to the thousandth to understand the process. We can do it just by going to the hundredth. Okay. I will say this: tonight's homework is a lot of work. So having 2 days to get your homework done would be a good thing. All right, so, well, 10.2 is entitled Approximating Square Roots, and it seems like we just did that. Yeah, I'm going to teach you a different method of approximation. So we have a general method for approximation. It kind of gets us to the closest number within a tenth or so. This is a method by hand to get us to as many decimal places as we would like without using a calculator. All right, so I am going to show you how to do it with a calculator first, and then we'll talk about how to do it by hand. All right, so here's where we stand so far with square roots. So square roots, there's the square root symbol. We call this the radical symbol, recall. And then the number that goes underneath the radical symbol is called the radicand. Okay, and what is the square root? Well, square root, ask yourself, what number multiplied by itself is the radicand? In other words, what number multiplied by itself is 9? Well, that number is 3. Well, 3 times 3 can be written as 3 squared, and squaring is the inverse of square rooting. So the square symbol and the square root symbol cancel each other out, and you're left with 3. Sounds like a whole lot of work. In reality, what happens is, just like the multiplication tables, we just memorize these things. What's the square root of 9? 3. What's the square root of 16? 4, so forth and so on. So this is the understanding or the theory behind why the square root of 9 is 3. But in general terms, we basically memorize those perfect squares so we can get to the answer much more quickly. All right, this works great, but sometimes we don't have perfect squares. 33 is not a perfect square. There is no integer multiplied by itself that is 33. There is no number. So how do we handle these? Well, we remember that the square root is the inverse of squaring. And so what we can do is we can think about some perfect squares that squeeze 33. In other words, the first perfect square that's smaller than 33 is 25. That's 5 squared. And the first perfect square that's larger than 33 is 36. The square root of 36 is 6, or 6 squared is 36. That's why we say the inverse of square root is squaring. Therefore, we know that the square root of 33 is somewhere between 5 and 6. And we can kind of take a guess. Let's see, 33 is closer to 36 than it is to 25. Well, midway between 5 and 6 would be 5.5. So I don't know what the square root of 33 is, but I know it's between 5 and 6. I'm guessing here, maybe it's 5.8. And that's a problem because I'm literally guessing. All right, but it is close. All right, let's see that one more time. The square root of 40, The first perfect square that's smaller than 40 is 36. The next perfect square that's larger than 40 is 49. That's 6 squared and 7 squared. So we know that the square root of 40 is somewhere between 6 and 7. Let's see, 40 is, well, it's 4 away from 36, and it's 9 away, so it's closer to 36, but it's kind of in the middle, so we wouldn't say 6.5. I don't know, 6.4, 6.3. Once again, I'm guessing. This technique gets us close, within a tenth or two, but it's certainly taking a guess. All right, one more. Square root of 5, perfect square would be square root of 4. Square root of 9, it's certainly closer to 5 than 4. So it must be close to 2, 2.1, 2.2, something like that. And once again, or last I'm saying I'm taking a guess. All right, so that's a quick review of what we've been doing. So go ahead in the Google Forms, there's 2 questions there for box 2. Go ahead and answer both of those. And then pause the video and then come back. All right, how'd you do? Let's see, 66. So that would be 64 and 81. So that's between 8 and 9. 66 is awfully close to 64, so 8.1, 8.2, something like that. It's certainly between 8 and 9, and I'm guessing that it's 8.1. Square root of 142, that would be 121 and 144. It's really close to 144. So that's between 11 and 12, so 11.9 maybe, 11.8, something like that. Okay. So hopefully I've made it clear that we are literally taking a guess here. Guessing is certainly sometimes mathematically prudent, other times it's not. Sometimes you need a much more accurate answer. So what do we do, right? We will need a more accurate answer. Well, we just calculated, or we just estimated the square root of 66 was about 8.1. Well, we all know that we can certainly take our calculator, type in 66, take the square root using the square root button. Remember, there's 2 types of calculators. Some calculators, you type the number in first and then the square root button. Other calculators, you hit the square root button first and then the number, and you'll figure out which calculator you have. And generally, the more expensive calculators, you hit the square root button first, and the cheaper calculators, you type the number in first. So using a calculator, the square root of 66 is, well, it's 8.12, so forth and so on. Notice that our guess of 8.1 was close. I mean, we had the first 2 digits right, an 8 and a 1. But we certainly didn't have a much more accurate answer than an 8.1. And by the way, it was a guess. It was an educated guess, but it was a guess. All right, so let's just quickly grab our calculators and let's do some square roots. So go ahead and answer the Google Forms box 3. This is using a calculator. I want you to round your answer to the nearest hundredth. Okay, so answer all 4 of those. It's just one question on Google Forms. You can separate your answers by commas or whatever makes you happy. Okay, so do those 4, please. All right, hopefully you didn't have any problems with this. Now, I did ask you to round to the nearest hundredth, just like I'll ask you tonight for homework. The square root of 13 is about 3.61. Notice I'm not putting an equal sign because I'm rounding. It's approximately. Square root of 101 is 10.05. Square root of 5 is 2.24. And the square root of 26 is 5.1. Notice that the last one rounded nearest hundredth. Well, that rounded to 5.1. Okay? All right, we good? Yeah, anyone can use a calculator. It's not that big of a deal. But, right, sometimes your calculator breaks. So what do? No, you don't grab for another calculator. Well, I guess if you have one, you can. But if you are asked to do this by hand, is there a process? And the answer is yes. Well, that's the good news. There is a process. The bad news is it's complicated. Okay, so this is one of those lessons where you're definitely going to want to use the pause button. Follow each step. I'm going to do 2 examples, then we'll do one together, and we'll have one that you do by yourself. So if you want to, keep going back and forth between the video and pausing it and playing it and fast forwarding and rewinding it, just so you can see the steps, by all means do that. All right, so the first thing I want you to do is get a piece of paper or in your notebook and just simply write down the steps. Don't worry about what they mean. We'll do all the steps one at a time. But these are the 4 steps. Okay, so go ahead and pause the video. Write down these steps, and then, like I said, we'll do 2 examples, just me doing one, and then we'll do one together, and then we'll wrap it up by having you do one all by yourself. So pause the video, write down the steps. Okay, like most things, sometimes when you're just writing down steps, it doesn't make much sense. All right, so let's see how this actually works. All right, so let's calculate the square root of 5. Well, we know the square root of 5 is just slightly bigger than the square root of 4, so our guess would be, I don't know, 2.1 was our guess. Well, let's see if we can get this more accurate, right, by hand. So step number 1 says estimate to 1 decimal place. In other words, take a guess. So we're going to guess it's about 2.1. Now, here's the beauty of this process. Even if you were to guess 2.2, this method works, okay? So certainly if you guess 3.1, it doesn't work too well. But, when you use your basic estimation strategy of 2.1, we're pretty darn close. Okay, so for those of you that need help on how to make that step 1 the guess, remember we squeeze it. It's between the square root of 4 and the square root of 9, so it's between 2 and 3. And I mean, it's only one more than 4, so 2.1 would be a pretty good guess. This method would still work if you guessed 2.2 or even 2.3. All right, so step number 1 is you take your guess, right? We're using what we did before. Okay. As I said, if you need to pause the video, replay the step, please do that. All right, step number 2, it says divide your guess. My guess was 2.1. Divide my guess into the radicand, right? So that means the number underneath the square root symbol. So I'm going to divide 2.1 into 5. And I need to take it out at least one more decimal place than what I need. We're going to round to the nearest hundredth, so I need to take this 3 decimal places out. So I need 2.1 into 5, 3 decimal places. That way, you'll see how we round as we get to the nearest hundredth. Okay. So 2.1 into 5. Well, 2.1 goes into 5. It goes what? Oh yeah, I got to move the decimal place once. So move that decimal place once. I always recommend moving the decimal place to the top to start off with. So now it's 21 into 50. 21 goes into 50 2 times. 2 times 21 is 42. Now I'm going to do this quickly. Just remember, this is just long division. So don't get hung up on how quickly I'm going to do this. Subtract, we get 8. Bring down to 0. 21 into 80 doesn't go 4 times, it goes 3 times. 3 times 21 is 63. Subtract, we get 17. Bring down another 0. 21 into 170 goes 6, 7 times, 8 times, maybe 8 times. 8 times 21 is 168. Yeah, that worked out right. Bring down the 2. Bring down another 0 would be 20. So I'd have to bring down another 0, so 200. So I'm actually going to get a 0 right there because 21 doesn't go into 20. Okay? So I took it out 3 decimal places because I'm trying to round to the nearest hundredth. Okay? So step number 2 is done, 2.380. Step number 3 is I got to average the divisor and the quotient. That means I'm going to average my answer, 2.380, and the divisor, which was 2.1. Play this again if you need to. So I'm going to average those 2 numbers. Well, when you average 2 numbers, that means add them up and divide by 2. So in other words, I'm averaging my divisor. My divisor was 2.1, and my quotient, that's your answer, 2.380, and then divide by 2. So I'm not going to show you all the work here, but 2.1 plus 2.380 divided by 2 is 2.24. 2.24. So that was step 3. Play this again if you need it slowly explained. All right, step number 4 says use this average. So what I do is I do 2.24 to 2 decimal places. Well, it is 2 decimal places. It won't always be. Sometimes it'll be more decimal places. So 2.24 is our answer. Square root of 5 is 2.24. If you want to confirm this, grab your calculator and do the square root of 5. You'll find it is 2.24, rounded to the nearest hundredth. So that's the process and how it works. So long division and multiplication with decimals. So it is fraught with error doing this by hand, but it can be done. So I said we're going to do 2 examples. You're going to watch me do 2 examples, and then we'll do one together. Okay, so there was example 1. If you want to pause, rewind, play it again, absolutely. You might want to watch one more example. Okay, let's do another example here. So let's see, square root of 8. So step number 1 says take a guess, estimate. So let's see, squeeze the square root of 8. That would be the square root of 4 and the square root of 9. Square root of 4 is 2, square root of 9 is 3. So it's somewhere between 2 and 3. 8's really close to 9, so I don't know, 2.9 would be my guess. All right. It says divide your guess into the radicand. So that would be 2.9 into 8. Does everyone see where I'm getting those numbers from, 2.9 and 8? So 2.9 was my guess. 8 is the radicand, the number under the square root that I was trying to calculate to the nearest hundredth. All right, so now it's just long division problem. So add a 0, move the decimal place once. 29 is awfully close to 30. 30 would go into 82 times. 2 times 29 is 58. I'm going to do this quickly. Just remember, it's just long division. You can pause. Subtract, that gives me 22. Let's see, add a 0. That's 220 now. 30 goes into 220 about 7 times. 7 times 29 is 203. Subtract, add a 0. 30 goes into 170 about 5 times. 5 times 29. Notice I keep saying 30. It just helps me try to take a good guess at it. But when I do the actual multiplication, I got to really use 29, not 30. So 5 times 29 is 145. Subtract. Add my 0. And 30 goes into 250, 8 times? Yeah. And 8 times. It doesn't matter. I've taken it to the nearest thousandth place right here. So we're good. We just got to go 1 decimal place more than what you need. So this is how you're going to do it tonight for homework as well, too. You're just going to take this to the thousandth place. But remember, this isn't the answer. What we have to do now, step 3, is we're going to average our answer, 2.758, with our divisor, 2.9. So I add 2.9 to 2.758, and then I divide that answer by 2, and I get 2.829. Now we're rounding to the nearest hundredth place, so that would be 2.83. So that's my answer to the square root of 8. Okay, so there was 2 examples. If you want to rewatch them again, maybe it'll come a bit more clearly. Or if you've got it, let's just move on. All right, so you ready to move on and do one? Yeah, you got this? All right, let's try one. Okay, square root 11, square root 11. Let's see, step number 1 is to estimate. So the 2 perfect squares that squeeze the square root of 11, that would be 9 and 16. Square root of 9 is 3, square root of 16 is 4. Let's see, 11 is closer to 9. It's 2 away from 9. It's 5 away from 16. So, well, it's not going to be 3.1. Maybe it's 3.2 or 3.3. Either one's fine. If you use 3.2, then you'll see that our math will be similar. Okay. And this would work with 3.3 as well, too. All right, so I need to take that number, 3.2, and divide it into 11. Do you see where I'm getting those numbers from? 3.2 and 11? All right. Let's see. So we need to move the decimal place once, move it straight up, just long division. That's 32. 32 goes into 110. 3 times. 3 times. 3 times 32 is 96. Subtract. Add a 0. So 30 into 140 is what, 4 times? Okay. So once again, notice I was rounding down just to help me with my guess. 4 times 32, 128. Okay, subtract. Add a 0. Remember, I got to take this to the thousandth place. I'm not right now at the 10th place. All right, so 32 into 120, 4 times would be too much, so it's 3 times. That would be 96. Subtract. Add a 0. And all I got to do is simply have a guess, and I'm done here. Let's see, 30 into 240 would be 8, but it's not 30, it's 32. So 8 would be too big, so it's got to be 7. Okay, so I took that to the nearest thousandth place. Step 3 says take your answer, your quotient, 3.437, add it to your divisor, 3.2, and then divide that sum by 2. In other words, take the quantity 3.2 plus 3.437, add them, and then divide by 2. All right, you do that math, you get your answer, and that is what we will round to find our final answer. So our final answer, rounded to the nearest hundredth, will be 3.32. So 3.32. And if you want to confirm that with the calculator, you can. And you're like, well, if I got a calculator, why would I be doing this? Well, just remember, right? This is the only true way. We could take this to the nearest 1 billionth if we wanted to. Um, I'm making you do this to the nearest hundredth. And this is a pretty good technique to know and to memorize so that you can always take a square root by hand, right? Especially when it's not a perfect square. All right, estimating it simply in your head, you can probably get to the nearest tenth, but to get past the tenth, you got to use this technique. All right, for those of you that are still lost, absolutely 100% rewind this, watch the three examples again, and then try the last one. For those of you ready, then let's move on. All right, so here's the one I want you guys to do all by yourself. Pause the video, get to an answer the last question on Google Forms, and then play the video and see if you got it right. How'd you do? Okay, so obviously this is a lot of math, right? We are doing this by hand. You certainly appreciate your calculator more when you see how this is done by hand. Okay, it's not like long division. Right? This has multiple steps. All right, so let's squeeze this sucker. Square root of 20 would be 16 and 25. It's 4 from 16. It's 5, so it's closer to 16, but it's awfully close to the middle. So, I mean, guessing 4.5 would be straight dab in the middle. I'm going to guess 4.4. Okay. Okay, so I take 4.4, step 2, and divide it into the radicand, which is 20. Right? Add a 0, move to decimal place. 44 into 200 is about 4 times. 4 times 44 is 176. Subtract, add a 0, 240. 44 to 240 5 times? Yeah. So that gives me what? 220. Subtract, we get 20. Add a 0. So what about 4 more times? 4.4, I'm sorry, 4 times 44 once again is 176. We get 24, and that would go, what, how many times more would it go? Yeah, it would go, 5 times. Okay, so there we go. We took it out to the nearest thousandths place. Okay, step number 3 says take your answer, your quotient, 4.545, average it with the divisor, which is 4.4. In other words, add 4.4 and 4.545, divide that answer by 2, and that in blue is what you're going to take to the nearest hundredth place for your answer. So 4.47. Okay, and that is your answer. All right, how'd you guys do? So this is one of those techniques in math that it's not. I don't know. I don't know anyone that gets a lot of fun doing this thing. Most people certainly scream for their calculators when they're asked to do this. But if you're ever asked to do this by hand, this is the technique that you got to do. So tonight for homework, there's not that many of them, right? I do want you to do some with a calculator, right? But the ones that say that you have to estimate, that is the technique. So you might want to have the video playing while you go through one example just to make sure you're doing all the steps right. Remember, you can always email me. You got basically a day and a half to get this done. So if you try it tonight and you run into problems, email me. You know, I can help you tomorrow via email. But if not, go ahead and get your homework done. And with that, I'll conclude the class. And have a wonderful day, and I will see you guys tomorrow.